Alana has a bookshelf with 5 shelves and has 30 different books, including finite mathematics and calculus. Okay, they're singling out some special books. I assume there's a good reason. If the books are put on the bookshelf at random, with 6 books on each shelf, okay, what is the probability that finite mathematics and calculus are on the same shelf? Okay. So we got 2 books singled out. How are we going to do this? And it's a probability question, but you can notice the language here very much, sort of the language of counting problems. We're arranging books on a shelf. That's things we've done before. So the probability we want is the number of ways to arrange with calculus and finite math book together on the same shelf. Well, let's just say on the same shelf. Divided by the total number of ways to arrange. Okay. So as usual, I start with the bottom one, sort of work that out as best I can. Okay. Now, let's see. Question here is let's say a little vague here. We've got 5 shelves. We don't know that they're different shelves, so you might have a question of indistinguishability. But I would say, probably bookshelves themselves are pretty distinct by their location. Okay. Books, you can have the same copy of a book and you can't tell them apart, but if I'm, 2 bookshelves can't occupy the same space, so you can refer to, this is the bookshelf in the upper left, upper right. So I would say the bookshelves are distinguishable, but we could easily change the question so they were indistinguishable. But I'm going to assume they're distinguishable. Okay. So how many ways can I arrange my books? Well, if you think about it sort of really intensely, you could say it's just 30 factorial. Right? Here are my bookshelves. No, they don't have to be in a line. But I got 30 choices for the book that's on the left of the first bookshelf, and then 29 for the next book, and 28, 27, 26, all the way down to my 25th book on the right of the first bookshelf. And then I go to whatever bookshelf I consider to be the next bookshelf, 24 choices and 23. You don't have to think about it that way. Okay. Instead, you can think about it as a sort of a series of groupings. I've got 30 books. I need a group of 6 for one shelf, a group of 6 for another, a group of 6 for another, a group of 6 for another, and a group of 6 for another. Having made those groups of books together, I then say, well, now that I've got my books, I know what books are going on the first bookshelf. I know what books are going on the wooden bookshelf or whatever they are. But I actually have to arrange them. So how many ways are there to arrange this group of 6 books along its shelf? 6 factorial. And then we arrange the next set of books on that shelf. 6 factorial and 6 factorial and 6 factorial and 6 factorial. But if you remember your multinomials from, 1.6, there's a formula for this. And it turns out all those 6 factorials will cancel out with all these other 6 factorials. And you're left with 30 factorial that way. So either way, we can see that the ways to arrange the books on the various shelves should be 30 factorial. So my probability is going to look like something over 30 factorial. Now we get into the harder question, the one that might involve some different cases or something like that. How many ways are there to arrange the books on the shelves so that the calculus and finite math books are on the same shelf, but they don't have to actually be like side by side? So I don't have to have calculus and finite math side by side. They just need to be in the same group. Okay? So, how do we break that down? So, number of ways to put the calc and finite math books on the same shelf. Okay, well, if I need them to be on the same shelf, first, I've got 5 shelves. I have started the question by assuming the shelves are distinguishable. So first, choose which shelf they go on. And I would say 5 choices for which shelf they go on. Right? Because I'm assuming that the shelves can be told apart just by their physical location in your room or on your bookcase. The top shelf, the middle shelf, and so on. Okay, so 5 choices as to which shelf they go on. Okay. And then I'm going to, just as we did before with multinomials, I'm going to make groups of books. Okay, so I choose which shelf they're going to go on. I make groups of books. So I need one group. And I'm going to put the calculus and finite math books in it together. Right? So if I imagine my groups of books that are going to go to my various shelves, I forcibly put, okay, calculus, finite math, you're in this group. Okay? Then of my remaining books, and there's 28 of them left to work with, I need to choose 4 of them to join that group so that I have 6 books to go on whatever shelf I have chosen. Then that leaves me with 24. Well, I still need a group of 6 to go on the next shelf, a group of 6 to go on the bottom shelf, group of 6, group of 6. Okay. So this is the number of ways that I sort of break them up into groups. So far, the number of ways to put the calculus and finite math books on the same shelf is 5, number of ways to choose your shelf, times the number of ways to split the books up into groups, ensuring that calculus and finite math are together. Okay. And then what do? Arrange the individual groups of 6 on their shelf. Okay? And that can be done, well, there's 6 factorial ways to arrange the first group of 6. And then 6 factorial ways to arrange the next group, and then 6 factorial, and then 6 factorial, and then 6 factorial. Okay? So in total, the number of ways to get the calculus and finite math books on the same shelf is 5 ways to choose the shelf, because I'm assuming that the bookshelves are distinguishable. 28, choose 4, choose 6, choose 6, choose 6. That makes the groups, including the one that's got the calc and finite math books together. Then times 6 factorials for arranging them all. Now we can do the same trick we pulled a moment ago and say, well, 28, choose 4, choose 6, choose 2. That's multinomial notation. I remember the formulas. And a lot of these 6 factorials are going to cancel out. Not all of them, but a lot of them. So here I'd say 5 times 28 factorial over 4 factorial times 6 factorial. And if we wanted to, if we really, really wanted to, we could go a step further. And say 5 times 28. 6 factorial is 6 times 5 factorial. I remember our factorial properties. And then 5 factorial is 5 times 4 factorial. And that will at least cancel out with the 4 factorial on the bottom. So I could say 6 times 5 times 5 times 28 factorial. And that's the number of ways to arrange the books on the shelves with the calculus and finite math books together on some shelf. Doesn't matter which one. So putting this all together, my probability is 6 times 5 times 5 times 28 factorial, all over the total 30 factorial ways of arranging the books without any care as to where they go. And again, you could do more, you can figure out that that's 150 without a calculator, but I would say that's a bit much. Okay. You could leave it with your multinomial notation. A perfectly valid answer would be 5 times the 28, 4, 6, 6, 6, 6. 6 factorial, 6 factorial, 6 factorial, 6 factorial. All over the 30. Choose 6, 6, 6, 6, 6. 6 factorial, 6 factorial, 6 factorial, 6 factorial, 6 factorial. Although, really, there, you definitely have a bunch of 6 factorials you're probably going to want to cancel out. But, yeah, there's lots of different ways to express the answer depending on how you sort of work through it.